Welcome to 4.5 Factoring Polynomials. If you have three terms in your polynomial, just use that same method that we've always used. Multiply the x to the fourth and the negative 27. Then we're going to try to add up to negative 6x squared. So I'm going to use negative 9x squared and 3x squared. So you'd have x to the fourth minus 9x squared plus 3x squared minus 27. Then we just group it. The first two in a group, they have x squared in common. That would leave x squared minus 9. The second two have a 3 in common. That would leave x squared minus 9. So you have x squared plus 3 times x squared minus 9. And then x squared plus 3 does not factor any further, but x squared minus 9 is a difference of two squares. X squared minus 3 squared. So you're actually going to use the square pattern on that one. It would be x plus 3x minus 3. So your final answer would be x squared plus 3 times x plus 3 times x minus 3. On the second one, there's actually a greatest common factor for all of those terms, and it would be 2x. They're all divisible by 2, and they're all divisible by x. So if I divide that out, I have 4x to the fourth minus 13x squared plus 9. Inside of those parentheses, I have three terms, so I'm going to multiply those two together. If I use negative 9x squared and negative 4x squared, that will add up to my negative 13x squared. So I've got 2x, 4x to the fourth, minus 9x squared, minus 4x squared, plus 9. And then I'm going to group inside of there, so I keep that 2x out front. The first two have an x squared in common. That would leave 4x squared minus 9. The second two have just a minus 1 in common. 4x squared minus 9. So I have 2x. Then I have I have 4x squared minus 9 and x squared minus 1. On that one, the 4x squared minus 9, that's a difference of two squares. I got 2x squared minus 3 squared. And the x squared minus 1 is a difference of squares. I have x squared minus 1 squared. So I'm going to keep that 2x. I'm going to go 2x plus 3, 2x minus 3 for that second one. And then the third one would be x plus 1, x minus 1. On example C, we're actually going to solve this one. So if we're going to solve by factoring, we're going to want to set it equal to 0 first. So we're going to minus 32x cubed over. So I'm going to have 4x to the sixth minus 32x cubed equals 0. Take out my GCF, which is 4x cubed. That will leave me x cubed minus 8. That cube part is the cube pattern. You have x cubed minus 2 cubed. So we have a 4x cubed. If we use that cube pattern, it would be x minus 2, x squared plus 2x plus 4 equals 0. The first one, easy to solve, x equals 0. Second one, easy to solve, x equals 2. Third one, I'm going to complete the square. So I'm going to actually subtract that 4 over. I'm going to add 2 divided by 2 squared. That's b over 2 squared. Add that to both sides. Factor, I have x plus 1. Quantity squared equals -4 plus 1 squared, which becomes a 1, so that side would be -3. If I square root both sides, x plus 1 squared cancels with the square root. So x plus 1 equals plus or minus. Bring that negative out, make it an I, square root of 3. And then last step, just subtract that 1 over. So you have 4 solutions. 0, 2, and then the plus part of that and the minus part of that. The last one for this lesson, letter D, that is 2 terms. We can square root 81, so we're actually going to use the square pattern. So if I square root x to the 4th, I have x squared. If I square root 81, I have 9. So that becomes x squared minus 9, x squared plus 9. I can't do anything with the plus. That one doesn't factor. Does not factor. The x squared minus 9 will factor. That's a difference of squares. So x plus 3, x minus 3. And then I still have that x squared plus 9. Solve, x equals -3. Solve that one, x equals +3. And then if I solve x squared plus 9 equals 0, I subtract the 9 over, and then I square root it. So I have x equals plus or minus 3i. Remember that negative under the radical becomes an I. Square root of 9 is 3. So again, there are 4 solutions. -3, +3, +3i, -3i. Hope that helps with 4.5 factoring polynomials. Thanks, and we'll see you next time.